Hello, uh, Engineering 1301, Fundamentals of Engineering. I got to go over a little bit of how to do handling technical information using Microsoft Excel in class, but I promised y'all a short video, so here you go. What you're seeing right here is the distance and time data. It says of launched projectiles here in example 1 on page 45. So you can certainly follow along with me if you want. I put it in the exact way it was here in the book. So if you typed it, this is what you'd get. And I like to sort my data so that it makes a little more sense to me. So I'm going to go ahead and grab all of the data here like that and go to data and sort. Then I can sort by distance or I can sort by time. So I'm going to choose distance. And then I'm going to sort from smallest to largest. Click OK. Now I go from 75 to 135. You can do that with all kinds of data. It won't change too much on this particular example, but it just makes it look a little nicer. And in the example here, they have time versus distance. So if you want to do time versus distance, then let's just go ahead and do that. I like distance versus time better, but I'll follow the example. So if I grab all of it here, whatever is in the leftmost column when you grab 2 is generally it's gonna treat it like it's X in Excel, and the one in the rightmost is going to treat it as Y. So I'm grabbing both of those, and I'm going to go to Insert, and over here to Scatter, and just click on the regular scatter plot. And so I've got what looks pretty close to what you see in your book, but I'm going to clean it up to use the good figure work that you know I want to see as I made in that document. So get rid of this title, get rid of the legend there that we don't need, get rid of these extra horizontal grid lines, scale it to look more like a square, and we're getting rid of the dead space over here. So my minimum one is 75, so let's just say I'll stop at 70 on my x-axis. So right click on the axis, go down to Format Axis. Under minimum, click on Fixed instead of Auto and change it to whatever you want it to be. Click in 70, close. So now it's changed it, but I feel like I want a little more markings more often than every 20, so I can double click it and get to the same thing. Under Major Unit, I'll change it from Auto to Fixed, let it be 10. And now I've got markings every 10, so it just looks a little better to me. And I've got dead space here from the time before 2 seconds. So I'll change, let's see, double click on that axis again. Go to minimum, change it from auto to fixed, and type in 2. And now I've got those lined up. And I'm going to click on the whole thing and make all this text bigger. I always say make the text as big as you can get away with. I think we can get away with at least 12. Let's say 14. That looks pretty good. Now I can see those numbers. And I'll put in my axes, click on the chart, go to Layout, Axis Primary Horizontal, Distance, feet. Always put in the label and the unit, unless it doesn't have a unit. Sometimes it doesn't. And then vertical is time in seconds. Just hit enter. And I'll make this a little bigger. If you want to add in grid lines, you certainly can. I usually put in both grid lines if I'm going to, both vertical and horizontal. So here's major, and here's major vertical. And I like to make these not so, make them more like a light gray so they don't take over the plot. Let's see if I get that right. Light gray, and then the horizontal one's also light gray. Format grid lines, solid line, there you go. Okay. And see, I'll make the chart area, I'll give it a border. Format plot area, border color, solid line, make it a dark black. Makes it stand out pretty well there. And I like to get rid of this border on the main chart. Okay, so that's a pretty good plot. going to change these marker options here. I like circles, and I'm going to make them where they're not filled. And make the line color perhaps, oh, not that line color, the marker line color. I'll keep it as a dark blue, but I'll make it a little thicker to 1 point. I don't know, that just looks a little better to me. So if you take that, you could turn this into a figure by just doing a regular copy, then opening up a Word document, right click, go all the way over here to this paste as picture, and then you can put in a caption by right clicking on it and saying insert caption, my caption text. Okay. And then I would make this bigger so that it doesn't seem so minuscule. Okay, there you go. So that's how you do each individual figure. So that gets you part of the way to this example. That was all the way through example 2. On example 3 here, they have the same data, but they want you to do formulas, and they want you to do a formula to calculate velocity, which of course is just distance over time. So I'm going to move this out of the way, and we'll do velocity, feet per second. So for the formula, type in equals and do distance. Click on the cell reference divided by time. So you have feet per second, units match. And now I've got all these. I'll just drag the corner down, it'll copy the formula. And of course I could get it to show more. If I have it on general, it'll show more digits, but I don't want it to have so many. So I click and just make it 1 decimal point. It looks nicer there. Make that bold, put a line underneath, and there you go. Okay, then it wants you to calculate some statistics. It says here, use Excel to calculate the average velocity of all projectiles. So I'll put a couple statistics here. Just for fun, we'll do average, we'll do standard deviation. How about we do median and something called coefficient variation. And some of these have units and some don't. So average, I'll just put down here just for your reference. You don't have to be able to do all this, but it might help you. So units, the average, the standard deviation, and the median, they're all going to have the same units as velocity. The coefficient of variation is not going to have a unit, really, and you'll see why. So average, just type in equals, average, and select everything that you want to make the average, and close your parentheses. And that should be your average. 23.5 seems workable to me. Standard deviation is standard DEV. That's one of them. You can read about some of the other ones. Grab all of them, and you got standard deviation. And then the same thing with median. That's one nice thing. They're always the same way to calculate. Grab it, close parentheses, there's your median. The coefficient of variation is CV equals the mean over the, the standard deviation over the mean. So it kind of gives you a dimensionless variation. So standard deviation divided by the mean, you can make that a percent and say basically there's generally about a 25% variation in the data relative to the mean in what you see here. And so, 5 or 6 is about 25% of here, about a quarter. So that fits well. So that was example 5. Display the velocities 1 decimal place on example 6. We really already did that. Then display the projectile velocities in inches of units. So they suggest doing conversion factors. So why not? You can put some conversion factors here. Conversion factor, we'll do 2, just for example. So this one will be inches in a foot. This one will be meters in a foot, 12 inches in a foot, and 0.3048 meters in a foot. So here's velocity inches per second and velocity meters per second. Oops. Okay. Bold, underline. So now you just 30 times the conversion factor. Let's see, actually you need to, to become inches. And you always want to use this conversion factor over and over and over again, so you want to use an absolute reference. So you can manually type in these dollar signs here, and that'll make it so that it's always using, if I copy it down, see it's still referring to this cell up here. So that one takes care of these here. If I want to get meters per second, use basically the same idea. Times this one. And if you want to use absolute, you can also just press F4, and it turns it straight to absolute reference. So now these are copied down. I'm going to get rid of these here. So now I've got feet per second, converted to inches per second, converted to meters per second, and you can do any other conversions there. So graphing, they're using this component heating example. Here's the data for that. Time and temperature. It's going to be something like a time series, basically. So it's already sorted by time here with the temperatures. It says copy the data above into an Excel spreadsheet and create a scatter plot of the data. We really already did that, but we'll look at it again. Grab everything. You can hold Control, Shift, and right, and Control, Shift, down. It'll grab all the data. I'm going to insert scatter plot here. Get rid of this title, get rid of this useless legend, get rid of these bars. Okay, and we'll put in, it teaches you how to add a legend or a chart title. I really don't think you need it in this data, so we're just not going to do that. So but let's go ahead and put in our axis titles, time, seconds, and temperature, Kelvin. Okay, get this to be box. Oops. Get rid of that boundary. Okay, so now it's looking pretty good. At least I know that it's something about being heated in time. And so they wanted you to put in the grid lines, both of them, so we'll just put in both like we did before. Insert major grid lines horizontal, major grid lines vertical. Now you can see the data move a little better in space. Now it says example 11, insert a trend line with an R-squared value of greater than 0.999 and error bars in the graph from Excel 1. Example 1. You'll click the data, then right click on it, go to add trend line, and if you want to you could put a linear one and you could see the equation R squared on the chart, but this R squared is not that great. 0.85 is a little low. You can see the line doesn't really, it misses a lot of the data there, so we can change the trend line to, now let's try, we could try a logarithmic, but it doesn't like that. So we're not going to do that. Let's change it to polynomial like it suggests. If you do one that's squared basically, it's like a parabola. And it's at 0.99, but they want 0.999. So you can see at the end we have more error. So if we right click on it and format the trend line to be cubic, now you've got 0.999. Or greater than 0.999. Let's see, I can't do that. And move it down so we can see it better. That should be what they got in here. That's pretty much all they want you to do except for these error bars. So you can go to here, layout, error bars. They want you to use percentage of 5%, so it means 5% of each value. So we'll click on this error bars here. It's got 5% already. So you see what that looks like. If we put in 25%, they should get a lot bigger. Those are very big error bars. And let's get rid of, we don't really need the error bars on the You can click over here, the error bars X. We really don't need those, so I'll just click on that and hit delete. Gets rid of those error bars. And we'll change this back to 5% like it said. 5%. Now, these other ones here, you could use a fixed value or some standard deviations as well. I often use fixed values. So that's pretty much the plot they've got there. Now if we had this one, you would say it's done. You could copy it and put it in your report after here. And just like before, right click, put the picture in, say right click, insert caption, and we'll say component heating over a 2-minute time span. It's about 2 minutes. And you can change anything you want to at this point. So I'll make that match. Okay, so there you go. You got your two figures now. Now you just got to figure out what they mean, but that's not really the purpose of this video. So have a good time with this, and please let me know if you have any more questions. I hope that Excel seems less and less scary the longer that we do this.